So, in this section, we will talk about the quotient rule. So, we will begin by considering two differentiable functions, f of x and g of x. Now, since both of them are differentiable, so we say that f of x divided by g of x, so the quotient is also differentiable. Meaning, if we take the derivative with respect to x of the quotient f of x over g of x, then this will be of the form. So start with the denominator. So in the denominator we have g of x. So we take the g of x and then square it. Then in the numerator, again we are going to start with the denominator g of x. Now this time we will multiply it to the derivative of the numerator, which is f of x. Unlike the product rule, in the quotient rule we have to use a minus. Now we have already taken the derivative of the numerator, which is f of x. So we will start with the f of x and multiply it to the derivative of the denominator. So if you want to check it out how this particular formula came, all you have to do is take f of x. We had divided by g of x. So if we take the g of x to the numerator, this is simply g of x raised to the power of negative half. So this becomes the product of two functions. One is f of x and the other is g of x whole raised to the power of negative 1. If we apply the product rule and do some algebraic manipulation, and this is what we should get. So I'll leave that as an exercise for you to try out. So we'll straight away dive into some problem. So let's consider the first example. So let's say we have a function f of x, which is a rational function, which have 3x minus 2 divided by 4x plus 5. So let's apply the quotient rule to find out the derivative of f of x. So this will be equals to, so we will begin by taking the denominator, which is 4x plus 5, and then we square it. Then in the numerator, we will again start with the denominator, 4x plus 5, and then multiply it to the derivative of the numerator, which is 3x minus 2. Then minus, now we will take the numerator 3x minus 2 and then multiply it to the derivative of denominator 4x plus 5. Right. So we have successfully applied the quotient rule. All that now remains is to find out the derivatives and simplify the expression on the right hand side. Let's do that. So we have 4x plus 5. So this will get multiplied to, so we have derivative of 3x minus 2. So I hope you are fairly comfortable with finding out the derivative as quickly as possible. So I will also try it out. So we have 3, which is a constant. So this will be 3 multiplied to derivative of x with respect to x, which is 1. Minus, we have a constant 2. So this will be 0. So that means derivative of 3x minus 2 simply gives us 3. Minus 3x minus 2 multiplied to, and performing the derivative in the similar fashion, so we will get 4. So this is divided by 4x plus 5 whole square. So we have, so let's distribute 3 with 4x plus 5. So we have 12x plus 15 minus 4 times 3x will be 12x. 4 times negative 2 is negative 8, and we already have a negative sign here, so this will be positive 8 divided by 4x plus 5 whole square. So the 12x gets cancelled out, and finally we get f prime of x, which is derivative of our function. So 15 plus 8, which is 23, divided by 4x plus 5 whole raised to the power of 2. So this is the derivative of our given function. So let's try out another problem. So we have our function h of x given by x squared divided by 1 plus x squared, which is another rational function. So we need to find out h prime of x. That means derivative of h of x. So let us begin. So we have h prime of x. So we'll apply the quotient rule to x squared over 1 plus x squared. So we will begin with the denominator. So that is 1 plus x squared whole raised to the power of 2. Then again we start with the denominator, which is 1 plus x squared, and multiply it to the derivative of the numerator, which is x squared. minus, since we already took the derivative of x squared, so we'll keep it outside and then multiply it to the derivative of the denominator, which is 1 plus x squared. So this gives us 1 plus x squared times derivative of x squared. So we use the power rule, so that will give us 2x minus x squared times, we have derivative of 1 with respect to x, so that's 0, plus derivative of x squared, so this is simply 2x whole divided by 1 plus x squared whole squared. So we have 1 multiplied to 2x, so that's 2x plus x squared multiplied to 2x, so that is 2x cubed. Minus x squared multiplied to 2x gives us 2x cubed divided by 1 plus x squared whole squared. So we can cancel out the second term and the third term, and this finally leaves us with 2x divided by 1 plus x squared whole squared. So this is the derivative of our function h of x, which we have obtained by applying the quotient rule. Let's move on to the next problem. So we have the function p of x given by square root of x over x squared plus 2. So let's find out the derivative with respect to x. So p prime of x will be equals to, so we will start with the denominator, which is x squared plus 2 whole squared. Again start with the denominator, x squared plus 2 multiplied to the derivative with respect to x of the numerator, which is square root of x, but we can write square root of x as x raised to the power of 1 over 2. Minus x raised to the power of 1 over 2 multiplied to the derivative of the denominator, which is x squared plus 2. So we have applied the quotient rule, so let's now simplify. So we have x squared plus 2 times half. So here we are applying the power rule, x raised to the power of half. So we have half times x raised to the power of half minus 1. So that is negative half. Minus x raised to the power of half times derivative of x squared. So this will be 2x plus derivative of 2, which is a constant. So that is 0. Divided by x squared plus 2 raised to the power of 2. Fine. So now what we can do, let's get rid of this particular x, which is x raised to the power of negative half. All we have to do is multiply both numerator and denominator with x raised to the power of positive half. So that means we get x squared plus 2. Okay, what we'll do, we'll multiply both numerator with 2 times x raised to the power of half. So we will multiply, so we have to do it to the denominator as well. So this takes care of this 2 as well, and x raised to the power of negative half. Minus, so we have 2 times x raised to the power of half multiplied to, so we have here 2x times x raised to the power of half divided by 2 times x raised to the power of half times x squared plus 2 whole squared, which will give us x squared plus 2 minus, so we have 2 times 2, so this is 4, x and x times x raised to the power of half times x raised to the power of half, which is simply x, and we already have an x here, so this will become x squared divided by 2 times x raised to the power of half times x squared plus 2 whole squared, or simply 2 minus 3x squared divided by 2 times square root of x. So x raised to the power of half is all simply square root of x multiplied to x squared plus 2 whole squared. So this is the derivative of our function p of x. Let's move on to the next problem. So we have the function L of x given by x plus 1 over e raised to the power x plus 2. So let's find out the derivative with respect to x. So we'll apply the quotient rule. So this will be e raised to the power of x plus 2 whole squared. Again, we start with the same denominator, e raised to the power of x plus 2. Multiply it to the derivative of the denominator, which is x plus 1. So derivative of x plus 1 is simply 1 minus the numerator times derivative of the denominator. So the derivative of e raised to the power of x plus 2 is e raised to the power of x plus 2 gets taken care of because the derivative of a constant is 0 and derivative of the exponential function is the function itself. So we have e raised to the power of x plus 2 minus, so we have x times e raised to the power of x minus e raised to the power of x divided by e raised to the power of x plus 2 whole squared. So the first term and the last term cancels out, and finally we have 2 minus x times e raised to the power of x divided by e raised to the power of x plus 2 whole squared. So this is the derivative of our function L of x. Let's move on to the final problem. So here we need to differentiate x raised to the power of 8 over e raised to the power of x. So let us consider this is represented by the function g of x. X raised to the power of 8 divided by e raised to the power of x. So we'll take the derivative on both sides with respect to x. So we will begin with the denominator. So we have e raised to the power of x whole squared. So in the numerator we have the denominator first, e raised to the power of x, multiplied to the derivative of x raised to the power of 8. So here we can use the power rule. So x raised to the power of 8 will become 8 times x raised to the power of 8 minus 1, which is 7, minus the numerator time derivative of the exponential function in the denominator, which is the function itself. So we can take e raised to the power of x as the common factor, multiply to 8 times x raised to the power of 7 minus x raised to the power of 8 divided by e raised to the power of x whole square. So we have 1 e raised to the power of x cancelling from both the numerator and the denominator. So this finally leaves us with, so we can have x raised to the power of 7 is the common factor, multiplied to 8 minus x divided by e raised to the power of x. So this is the derivative of the given function.